welcome everyone. Question says AC source of voltage connected from its two ends to a resistor with a resistance of 250 ohm. The potential difference between the two ends of the source is given. We are 500 sine 200 phi t. And it says write the relation that gives the current in the circuit. And B says calculate effective voltage and effective current, and C says calculate angular and natural frequency of the circuit. And the A says write the I R equal I max times sine omega d. Write this equation, the A says. And the given VR equal 500 times sine 200 pi t divided by both sides with the R. It's going to be IR equal 500 over R. R is given 250 times sine 200 pi t, and it's going to be IR equal to sine 200 pi t. This is the solution for the A. Now let's solve the B. B says calculate the effective current and the effective voltage, and V effective is equal V max times 0.707, and V max is this one is the V max 500 times 0.707, and it's going to be 353.5 volt. And I effective equal I max times 0.707. I max is equal, this one is the I max, as we calculate 2 times 0.707 is equal 1.414 ampere. C says calculate the angular and natural frequency of the circuit, and we know VR equal V max times sine omega t, and this is equal VR equal 500 sine 200 pi t. So that means sine omega t equal sine 200 pi t. It means omega t equal 200 pi t. T and t cancel each other. Omega equal 200 pi. This is the angular frequency, and let's calculate the natural frequency. Omega is equals 2 pi f, so this is equal 200 pi. 2 pi and 200 cancel each other, that is 100, so f equals 100 hertz. Thanks for listening. Hello, welcome everyone. An oscillating electromagnetic circuit consisting of capacitor with capacitance 50 over pi microfarad and inductor with inductance 5 over pi millihenry. Calculate natural frequency of circuit and angular frequency of circuit. That means circuit in resonance. We have to use resonance frequency Fr equals 1 over 2 pi root of LC. And the F is the natural frequency, omega is the angular frequency. So it's going to be 1 over 2 pi root of L is equal 5 over pi times 10 to minus 3, C equal 50 over pi times 10 to minus 6. Pi and pi, over pi squared, it will be out pi, so this pi cancel each other. In a short way, the result is going to be 10 to 3 Hertz. For the B, we have to calculate omega R. Omega R equal here to pi F R. So 2 pi times Fr 10 to 3, it's going to be 2 times pi times 10 to 3 Hertz. Thanks for listening. Hello, welcome everyone. Question says an electrical oscillator with a constant potential difference 1.5 volt. If its frequency change 1 Hz to 1 MHz, calculate both impedance and current in the circuit. Both then are connected to resistor, capacitor, and inductor. Calculate the A. It's asking calculate impedance and the current. So we have to calculate Z and I. For the AC circuit, if there is only resistor, Z equal R. Z equal R, and that means they are equal 30 ohm. And the current equals V over Z for the AC circuit. V is 1.5 over Z equal 30, so it's going to be 0.05 ampere. This is for 1 Hz and 1 megahertz. It does not change for 1 Hz or for 1 megahertz. These are affected capacitance and inductance. They are not affected on the resistance. To calculate B, there is capacitor. Capacitor equal 1 over pi microfarad. C equal 1 over pi times 10 to minus 6 farad. We are going to calculate it for frequency equal 1 Hz and frequency equal 1 megahertz. The first one, F equals 1 Hz. In this choice, Z equals XC because there is only capacitors, so there is only inductive reactance. So Z equals XC, and XC equals 1 over 2 pi FC. And 1 over 2 pi times F is 1 times C is 1 over pi times 10 to minus 6. It will be 0.5 times 10 to 6 ohm. So current going to be V over Z. It means V over XC. So V equal 1.5 over X equal 0.5 times 10 to 6. It will be 3 times 10 to the power of minus 6 ampere. And we have to calculate impedance and current for the frequency 1 megahertz. Now F is equals 1 megahertz. Z equal XC 1 over 2 pi FC equal 1 over 2 pi times F 1 megahertz, mega means 10 to 6 times 1 over pi times 10 to minus 6. And pi cancel each other, 10 to 6 and 10 to minus 6 cancel each other. The result going to be 0.5 ohm. We have to calculate current. Current equal V over Z. It means V over XC. V is 1.5 over XC equals 0.5. Result going to be 3 ampere. Calculate C. L equal 50 over pi times 10 to minus 3 Henry. And for the C also there is two frequency. First one is F equal 1 Hertz. There is only inductor in the circuit. Z equal X L directly. Current equal V over Z. It means V over XL. XL equal 2 pi FL. 2 pi times F1 times L equal 50 over pi times 10 to minus 3. Pi and pi cancel each other. 2 times 50, 100. It's going to be 0.1 ohm. Current equal V over XL from this formula. V over XL. V equal 1.5 over XL equals 0.1. So it's going to be 15 ampere. And for the F equal 1 megahertz. XL going to be 2 pi FL. 2 pi times F now 10 to 6 because it's megahertz times L is 50 over pi times 10 to minus 6. The result going to be 0.1 times 10 to power of 6. And the unit of it is going to be ohm. The current equals 1.5 over 0.1 times 10 to 6. The result going to be, let's write the result here. Current going to be 15 times 10 to the power of minus 6 ampere. This is the whole solution for the C. Thanks for listening. Hello, welcome everyone. Coil is connected to two poles of a battery with a potential difference 20 volts. The current is 5 ampere in the circuit. If the battery removed and the coil is connected to poles of an AC source, effective voltage 20, frequency 700 over 22, and current 4 ampere. A says calculate the self-induction. L, R circuit, there is resistance and the inductor in this circuit. How can we understand there is resistance? Because potential difference of the DC given and current of DC given, it means it says to calculate resistance of resistor. So R equal V over I, and we have to use for this one DC properties, potential difference 20 and the current in the circuit 5 ampere, so it's going to be 4 ohm. Effective voltage given 20 and the current in the circuit given 4 ampere, so I can calculate the total impedance, which is equal V total over I total 20 over 4, it's equals 5 ohm. Total impedance formula is equal Z square equal R squared plus X squared, but in this circuit there is no capacitor, so directly XL squared. Z is 5 squared is equal R 4 squared plus XL squared. And the XL going to be 3 ohm. Formula of the XL equal 2 pi FL. XL we found it is a 3 equal 2. And the value of pi is 22 over 7. Because frequency given 700 over 22 times L. So L going to be 15 times 10 to minus 3 Henry. B says calculate the phase difference angle. To calculate phase difference angle, we have to use tangent phi always. Tangent phi equal x over r, but there is no x as I said, so it's going to be xl over r. XL is 3 over r is 4, so it's going to be 0.75, and the angle, which is phi, going to be 37 degree. From this triangle you can calculate it. 37, 53. There is 3, 4, and 5. Tangent 3 over 4, it means 37 degree. C says power factor. Power factor means cosine phi. Cosine phi equal R over Z. R is equal 4, Z is equal 5, it's going to be 0.8. Let's solve the D, and D says calculate the both actual and real power. P real equal I square times R. I is 4 square times 4. And which current we are going to use here? If you want to decide that, we have to use 4 ampere. Why? Now we are talking about the AC circuit. The information which is given about the battery is to calculate resistance. So the result going to be 16 times 4, 64 watt. And the P apparent is going to be I times V total equal I is 4 and V total is equal 20. It's going to be 80 volt ampere. Thanks for listening. Hello, welcome welcome everyone. A resistor 150 ohm is connected to coil with neglected resistance that has self-inductance of 0.2 Henry and a capacitor. The group connected pulse of AC source with the frequency 500 over pi Hz and the potential difference 300 volt. Calculate the amount of A, capacitance of capacitor that makes total reactance in the circuit 150 ohm. It means, so A, it means if the total reactance Z equals 150 ohm, and we know it's from the question, it's equal R. When the Z equal R in RLC circuit, it means XL equal XC. Formula of XL to pi FL equal 1 over 2 pi FC. Question says calculate the capacitance, that means C. It's going to be 1 over 2 pi F square times L, and it's going to be 1 over 2 pi times F is 500 over pi squared times L is equal 0.2. So C is going to be 5 times 10 to the power of minus 6 coulomb. B, it says calculate the power factor. Power factor equal cosine phi, and the cosine phi equal R over Z. R is equal 150, Z equal 150, it's given. So it's going to be 1. In which degree cosine equal 1? When it is 0 degree. Let's solve C. C says Phasor diagram of impedance. Phasor diagram of impedance. Let's draw it. That is XL, that is XC, and that is R. And XL equal XC. So Z equals R. D says current in the circuit. Current equal V over Z. And here Z equal R. Potential difference is equal 300 over R equals 150. Result going to be 2 ampere. And E says calculate the actual and apparent power. Actual power means P real. P real equal I R squared times R. And we calculate the current. There is a 2 ampere, 2 squared times R, which is 150, equals 600 watt. And the P apparent is going to be I total times V total. I total is 2, V total is 300. It's going to be 600 volt ampere. Thanks for listening. Hello, welcome everyone. An AC circuit contains resistor, capacitor of capacitance 20 microfarad and inductor, and they are all parallel. Group connected to AC source 100 volt, frequency 100 over pi, actual power 80 watt, and power factor 0.8. And circuit has inductive property. That means IL greater than IC if the circuit has inductive property. A says the current in the resistor and the current in capacitor. Current in resistor, how can we calculate it? By using the actual real power, P real equal IR times VR. And this is the parallel combination. Potential difference are same. So P real is equal 80 IR times VR is equal 100. So IR going to be 0.8 ampere. IC equal VC over XC. VC equal V total. They are all equal each other because this is a parallel combination. It is 100. But what about the XC? XC unknown, just the capacitance given. So I have to calculate XC. X equal 1 over 2 pi F, which is 100 over pi times C, and C 20 times 10 to the power of minus 6 farad, and XC going to be 250 ohm. So IC going to be 100 over 250. It will be equal 0.4 ampere. Now let's solve the B. B says total current. To calculate total current, I'm going to use formula of power factor, because power factor given, it is the cosine phi, and it's equal IR over I total. Power factor given, which is 0.8. IR we calculated as a 0.8 over I total. So I total going to be 1 ampere. C, choice of C says power factor, it is given in the question already, and phasor diagram of current. Phasor diagram, let's draw the phasor diagram for the current. This is the IR, IC, and IL. And question says circuit inductive property carries the inductive property. So I total going to be fourth region. This is the phase difference angle. And D says self-induction of the inductor. That means we have to calculate L. How can we calculate L? From the XL. XL equal to pi FL. And how can I calculate the XL? L equal V over IL. So I have to calculate IL. And from the total formula, I total squared equal IR squared plus IX squared. That means IC minus IL. Or let's write it directly, IX squared. And I total is 1 squared. IR is equal 0.8 squared plus IX squared. Ix going to be positive or negative 0.6. But which one it will be? Which one it will be? Ix equal IC minus IL. So circuit inductive property. So IL greater than IC. If the IL greater than IC, the result must be negative. So the correct answer for this one, negative 0.6. It will be negative 0.6. IC minus IL going to be negative 0.6. IC we calculate it's equal 0.4. 0.4 minus IL equal negative 0.6. So IL going to be 1 ampere. Now I can calculate the XL. XL equal 100 over IL, which is 1. So it's going to be 100 ohm. By using this, XL equal 2 pi FL. So L equal XL over 2 pi F. XL is 100 over 2 pi times F. F is 100 over pi. It's going to be 1 over 2. That means 0.5 Henry. Thanks for listening. Hello, welcome everyone. A resistor, an inductor, and capacitor are connected in series and connected to the end of 200 volt source. Frequency 100 over pi hertz. Resistance of inductor 20 ohm. Self-inductance 0.5, and it's connected to 10 ohm resistor. Power factor is 0.6, and the circuit has capacitive property. The important information about this question. It says calculate impedance and current. It says calculate impedance and current in the circuit, and resistance in the circuit are total equal 10 ohm plus 20 ohm. Why? There is two resistance in inductor and in resistance. So it's overall going to be 30 ohm. Power factor given, which is cosine phi equal R over Z. And power factor given, power factor equal 0.6. So 0.6 equal R is 30 over Z. Z will be 50 ohm. And the current in the circuit going to be V total over Z. V total is given 200 over Z equal 50, so it will be 4 ampere. for B, he says calculate the capacitance of capacitor. To calculate capacitance, how can I calculate the capacitance? From the XC, because X equals 1 over 2 pi FC. So that means I have to calculate XC. And how can I calculate XC? Z square equal R square plus XL minus XC squared. And I have to calculate XL. XL is not given. XL equals 2 pi FL, but the L given. 2 pi times F is equal 100 over pi times L is equal 0.5. So it's going to be 100 ohm. And X equal XL minus XC. There was an information. That information say to us the circuit have capacitive property. If the circuit capacitive property, the result of this is going to be negative value. So Z squared, Z which is 50 squared is equal R squared, R is 30 squared plus XL, as we calculate 100 minus XC squared. 100 minus XC can be negative 40 or positive 40, but it says positive property, so it's going to be negative 40. XC going to be 140 ohm. So 140 equal 1 over 2 pi times F is 100 over pi times C. So C will be 1 over 200 times 140. So it will be 35.7 times 10 to minus 6 farad. Now, C says draw the Phasor diagram of impedance. To draw Phasor diagram of impedance, we are using one way. Here there is XL, here there is XC, and here there is R. And what about the Z? First region or fourth region? We have to decide that, but the question says capacitive property. So it means XC greater than XL. So that's going to be here. And this is the phi, which is phase difference angle. And D says phase difference angle, which is tangent phi equal X over R. Tangent phi equal X means XL minus XC. So 100 minus 140 over R is equal 30. Tangent phi going to be minus 40 over 30, it means minus 4 over 3. So phi equal minus negative 53 degree. And it's in fourth region, it must be negative value. So we are correct. Thanks for listening. Hello, welcome everyone. 10 microfarad capacitor, 0.125 Henry inductor, and 150 ohm resistor. They are in series. They connected 500 volt battery, 400 radian/second angular frequency, A impedance, and current. A calculate impedance and current. To calculate impedance, Z square equals to R squared plus XL minus XC squared. I have to calculate XL and XC. XL equal omega L. Omega is 400 times L is 0.125. It's going to be 50 ohm. And XC equal 1 over omega C. It means 1 over omega 400 times C is 10 times 10 to the power of minus 6 farad. And it's going to be 250 ohm. Now Z squared equals to 150 squared plus XL 50 minus XC 250 squared. So Z equal 250 ohm. And current in the circuit, current equal V over Z. Potential difference, which is 500 over Z 250, is going to be 2 ampere in circuit. B, it says voltage on resistor, inductor, and capacitor. We are equal I times R. I is 2 times R 150 equal 300 volt. VL equal I times XL. I is 2, XL equal 50, so result 100 volt. And VC equal I times XC. I is 2, XC is 250, and it's going to be 500 volt. And C says calculate the phase difference angle and characteristic of circuit. Calculate phase difference angle, we have to use tangent phi always. Tangent phi equal XL minus XC over R. XL 50 minus XL 250 over R. R is 150. So the result going to be minus 200 over 150. It means minus 4 over 3. For the minus 4 over 3, phi is going to be minus 53 degree. And it says calculate the characteristic of circuit XC greater than XL. So circuit has capacitive properties. For the D says calculate the power factor. Power factor is cosine phi, and cosine phi equal R over Z. R is 150 over Z 250. It's going to be 3 over 5. That means it equals 0.6. Thanks for listening. Hello, welcome everyone. Alternating current circuit contains pure resistor, pure capacitor, and pure inductor in parallel. Circuit potential difference 480 volt, frequency 100 Hz, actual power 1920, capacitive reactance 32, inductive reactance 40, and find a current on each resistor, capacitor, inductor, and main current. They asking calculate the currents. And P real given, P real equal IR times VR. P real 1920 equal IR times VR. In this question, it's connected parallel, so it means VR, VC, VL, V total, they are all equal each other, so they are all equal to 480. So IR going to be 4 ampere, and IL equal VL over XL. VL equal 480 over XL equal 40. So the result is going to be 12 ampere. And IC equal VC over XC. VC also 480 over X equal 32. So the result is going to be 15 ampere. And question says also calculate the main current. That means I total. I total square equal I R squared plus IC minus IL squared. So I total squared equal IR is 4 squared plus IC is 15 minus IL is 12 squared. So I total going to be equal 5 ampere. P says throw the phase vector IC, IR, and the IL. And the I total going to be in first region. Why? Because IC greater than IL. Also, circuit capacitive property C. C says phase difference angle and properties of circuit. Phase difference angle tangent phi equal Ix over IR equal IC minus IL over IR. IC is 15 minus IL is 12 over IR is 4. So it's going to be 3 over 4. So the angle going to be 37 degree, and the circuit has capacitive properties. This says power factor. Power factor equal cosine phi. Cosine phi equal IR over IT. IR is 4. I total is 5. It's going to be 0.8. And E says total reactance in the circuit. That means he asking what is the Z. Z equal V total over I total. V total is equals 480 over I total as we calculate 5. And it's going to be 96 ohm. Thanks for listening. Hello, welcome everyone. A resistor with 30 ohm resistance connected pure capacitor in parallel. System connected, pulse of alternating voltage. Frequency 50 Hz, total reactance 24 ohm, actual power 480. What's the amount of capacitance, and draw the phasor diagram of current. So let's calculate first of all the real let's calculate first of all current in resistor. So I have to use real formula equal I square times R. So I square times R is 30 is equals 480. When they cancel each other, it will be 16. I square will equal 16. So I are going to be 4 ampere. And I have to calculate potential difference. VR equal IR times R. IR is 4, R is 30, so we are going to be 120 volt. VR and the VC and the V total, they are all equal to each other. That means they are all 120 volt. And Z equal V total over I total. That is given 24 equal V total is 120 over I total. So I total going to be 5 ampere. I total squared equal IR squared plus IC squared, because there is only capacitor and resistor in this circuit. So I total is 5 squared equal IR is 4 squared plus IC squared. So IC going to be 3 ampere. And now I can calculate the XC. XC equal potential difference of capacitor over current of capacitor. Potential difference of 120 over current is equal 3. It's going to be 40 ohm. So XC equal 1 over 2 pi FC. So C equal 1 over 2 pi F times XC. So it will be 1 over 2 pi times F50 times XC is equal 40 as we calculate. So C is going to be equal 1 over 4000 pi farad. And we calculate the C, and the equation says draw the phasor diagram. In this circuit there is only R and C, so there is IC and IR, and I total will be here, of course, in first region, and this is the phase difference angle. Thanks for listening. Hello, welcome everyone. Alternating current circuit connected in series, which has coil with resistance 500 ohm and variable capacitor. When the circuit has 50 nanofarad capacitor and alternating voltage of 400 volt, angular velocity is equal to 4 radian over second, and actual power equal apparent power in the circuit. The AC is calculate coefficient of self-induction and current. For the A, there is hidden information in the question. It says actual power is equal apparent power. That means circuit in resonance. So when the circuit in resonance, we have formula for the angular velocity omega r equal 1 over root of L C, and C is given, and A says calculate the L. So if I take the square to both sides, it's going to be omega square equal 1 over LC. So L equal 1 over C times omega R squared. So let's substitute the value. L equal 1 over C is 50 nanofarad. 50 times 10 to minus 9 times omega is 10 to 4, and we have to take square. It's going to be 10 to 8. 10 to 8 and 10 to minus 9 are going to cancel each other. It will be 10 to minus 1. 10 to minus 1 and 50. 1 over 50 times 10 to minus 1. It's going to be 1 over 5. So it will be 0.2 Henry, which is the self-induction coefficient. And also question says calculate the current. And current equal V over Z. V is given in the question 400. And Z, what about the Z? In this question, if it is in resonance, Z equal R in resonance. So R equal 500, 400 over 500, it's going to be 0.8 ampere. And B says in inductive reactance and capacitive reactance, when the circuit in resonance, it means XL equal XC. If I calculate one of it, that means I have calculated already both. So let's calculate XL. XL equal omega times L. Omega is 10 to 4 times L is 0.2. So the result going to be 2000 ohm. And this one also equal XC. For the C says calculate the phase difference angle and power. To calculate phase difference angle, we have to use tangent phi. Tangent phi equal XL minus XC over R. And XL and XC are equal each other. So when you subtract them, it's going to be 0. 0 over 500 going to be 0. So the angle phi going to be 0. And let's calculate the power. Power is equal I square times R. If I calculate the real power, it's equal accurate power as it written in the question. I is 0.8 squared times R is 500. So it will be equal 320 watt. And D says calculate the quality factor. Quality factor formula is equal 1 over R root of L over C. So 1 over R is 500, root of L is 0.2 over 50 times 10 to minus 9. And it will be 1 over 500 root of 0.2 over 5 times 10 to minus 8. Now I'm going to write directly result in a short way. It's going to be 4. And the question in E, it says the capacitance of capacitor that makes the phase vector for the total voltage falls behind This is important. It says behind the current phase vector by an angle of pi over 4. It means tangent pi over 4, but it must be negative pi over 4. Why? As I said, it says behind. If it is behind, it's going to be negative. It's equal XL minus XC over R. And pi over 4 or negative pi over 4 equal minus 45 degree. Tangent minus 45 equal minus 1. So minus 1 equal XL is 2000 minus, now XC is unknown because it says capacitance of capacitor only, over R. R is 500 minus 500 equal 2000 minus XC. It's going to be XC equal 2500 ohm. And question, and E says capacitance of capacitor, calculate the capacitance of capacitor that makes the phase vector for the total voltage fall behind the current phase vector by an angle pi over 4. And it says fall behind, so angle will be negative value, so minus pi over 4. Minus pi over 4 means minus 45 degree. And how can we calculate the capacitance from the XC? X equal 1 over omega C. So first of all, I have to calculate XC. To calculate XC, I am going to use tangent phi equal XL minus XC over R. Tangent phi going to be tangent minus 45 equal XL minus XC over R. Tangent minus 45 going to be minus 1. XL is 2000 minus XC over R is 500. So XC going to be 2500 ohm. And now I can calculate the capacitance. XC equal 1 over omega C. So C equal 1 over omega times XC. When I substitute the value of omega and XC, omega 10 to 4 times XC is 2500. It's going to be C equal 4 times 10 to the power of minus 8 farad. Thanks for listening.